Today I'm going to explain ventilation mechanics using a 3D lung model. So I have these two balloons that are taped to straws. My balloons will be the lungs, and the straws will be like the bronchi and the trachea. I also have a bottle. I cut off the bottom, and I have this balloon which will go on the bottom, will stretch over the bottom and act as the diaphragm. Okay, here's my lung model. I put the balloon, I stretched it over the bottom, and then I connected two balloons inside to the straws, and it's fastened here by the sticky stuff, which prevents air from going in and out through that hole. This is my 3D lung model at rest. This shows the state of the lungs between the breaths. There's no difference in pressure between the alveolar pressure, which is the pressure inside the lungs, and the barometric pressure, which is also atmospheric pressure. Okay, this bottom balloon acts as the diaphragm. So as I pull it down, the space in the thoracic cavity, or the bottle, increases because the height of the space increases. This is basically the diaphragm contracting and flattening due to nerve stimulation. Though it is not shown in the human body, there are also external intercostal muscles, which are muscles between the ribs that contract to expand the circumference of the thoracic cavity. So back to this model. As the volume of the lungs increase, according to Boyle's law, the pressure inside the lungs decrease. Boyle's law states that pressure is inversely related to volume. Basically, that means that if there's higher pressure, then the volume is decreased. Because air moves from high to low pressure, and that the lungs right now have lower pressure than that of the atmosphere, air goes into the lungs. This is inspiration. So it expands, the balloons expand. At the end of inspiration, the pressures, which are alveolar pressure and barometric pressure, they're equal again. So as I hold it out like this, nothing happens. This is kind of similar to how the lungs are at rest. Next is exhaling or expiration. I can do that on this model by bringing the diaphragm from inspiration back to its normal state, which is just pushing it back up. As I do this, the volume of the lungs decrease, and according to Boyle's law again, the pressure increases. When the pressure in the lungs is more than barometric pressure, air moves out of the lungs. In the human body, expiration also occurs when the expiration occurs when the nerve stimulation pauses and when the external intercostal muscles relax. Also, as the diaphragm moves back up, elastic fibers around the alveoli, or the air sacs of the lungs, recoil, bringing the alveoli back to their at-rest states. So, notice how when I bring the diaphragm down, the balloons expand. That means the lungs expand. And when I bring it back up, the air moves out, so they kind of contract. So what I can show you with this model is called quiet expiration. However, you can also force expiration. I'm not able to use the model to show you, but when you force expiration, accessory muscles called internal intercostal muscles are recruited. These internal intercostal muscles are located just underneath the external intercostal muscles in between the ribs. And at the end of expiration, the alveolar and barometric pressures are equal, and the lungs are in between breaths and at rest again.